So hello everyone, this is Coderunner, and in this video I'm going to explain this problem, that is stock span problem. And in this problem we have given a series of daily prices codes for a stock, and we need to calculate the span of stock's price of all n days. So the span of SI of stock price on a given day I is defined as the maximum number of consecutive days just before the given day. So for the price of the stock on the given day is less than or equal to its price on the current day. So for example, if an array of 7 days prices is given, that is 100, 80, 60, 70, 60, 75, 85, then span values of the corresponding 7 days are, that is 1 1, 111, 2 1, 4 6. So basically is it very typical question after reading this. So I will simply explain this what we have to do in this question. So basically we have given the total number of that is size of an array, that is size of price array, and we need to return, we can say, minimum number of we have to return the stocks of the given day which is less than or equal to its price on the current day. So for example, so we have to consider that particular index also. So for example, this is index 0, this is index 1, this is index 2, this is index 3, this is index 4, this is index 5, this is index 6. So we need to simply store the value, we can say current profit or equal to that day. We have to, for example, for 100 there is no left greater element, so we have to store, or we can also compare the current index also, so we have to return 1. Next we have to return, that is we have to return the consecutive. So here 1, 60 also there is no consecutive before the 60, so this is also 1. So at the place of, that is at the index of 70, there is one consecutive, that is 60 and 70, so there are 2. So at third index we need to return 2. Yeah, at third index we need to return 2. And 60 there is no consecutive, we can say no consecutive number on the left side of that 60, so we will return 1. So and there are, we can say, one consecutive number is this 60, 70, 60 and 75 also. So there are 4 consecutive number, we can say less than or we can say equal to that of 75, so this will be 4. And last index, that is 85, so we have, that is 1 2 3 4 5, and we will consider this also. So 1 2 3 4 5 and 6, so we need to return 6. So here what we are doing here is simply we are simply looking the values in the left side of the array, and if we are getting the consecutive number, or we can say less than less than that particular element less than that index at that particular element, and at that particular index, so we need to return the number of element. If for example in this case, that is at 100 there is no element, so we need to compare less than or equal to of that particular element. So there is only one, that is 100 itself is only one, we can say there is a smaller element than 100 or equal to 100. So we have simply written here 100, that is 1, sorry, and index that is index 1 at 80. There is also no element less than 80, we can say. So we can say we need to return 1 because 80 is equal to 80, and there also 1 at index 70, that is at 70 we have one index. That is at index 60 there is no, so we have to return 1. At index 70 we have 2, that is 60 and 80, sorry 60 and 70, there are 2, we can say 2 element which is equal to or less than that element. So what we are doing here is simply the approach is we need to find the we can say next uh, next greater, we can say next smaller left element, or we can say nearest smaller, we are looking for nearest smallest number, or we can say smallest consecutive numbers, and nearest smallest consecutive numbers, consecutive numbers. So simply I will write simply with the help of this manual keyboard. So we are looking for consecutive and we can say consecutive nearest smallest element, nearest smallest element. So simply we need to find the we can say we need to simply find the nearest left element, and we need to store that. So simply how we are getting this resultant vector, so how we are getting this, so we need to know the whole process so that we can simply implement our logic into a code. So simply we'll deep dive this into this logic, that how we are getting this output. So simply what we are doing is step 1, that is we can say step 1, we are looking for example there is, that is step 1, first step, we are finding the, we can say nearest, we can say nearest consecutive number or smaller number to the left. So for example I have taken an array, that is empty vector, or we can say array, or we can say vector. So I have taken a vector, and now I will see, is there an element which is in left that is equal to 100, sorry less than 100? No, there is no element, so I will return -1. So I will put my into my vector, that is -1, this is index 0, and for 80 also there is we can say no no element less than 80, so we will return -1. So let me check if I am doing wrong or right. Okay, we need to store the indexes of this. We need what we will do is simply step 1 is we will simply, this is step 1. Simply I will what I will do is I will store the indexes of we can say nearest left nearest smallest left element. So for 100 there is no element less than less than 100 on the left side, because there is no element in present in on the left side. So I will simply return -1 at index 0. Now what I will do is simply I will see is there is any element less than 80. So there is no element less than, I can say, less than 80, so I will return 0. This is index 1. And 60 also. There is no I can say there is no element less than 60, so this is also 1. This is index 0, this is index 1, this is index 2, this is index 3, this is index 4, index 5, this is index 6. So here we are doing is simply we are finding the element greater on the left side. So for example, for 80 there is one element greater than, we can say, on the left side that has index 0. So we have simply uh, simply store store into it our this is answer vector. And in index 2 there is 60. So nearest, I can say, nearest greater element of 60 is 80. So we need to store the index of 80, that is 1. So we have stored that in our answer vector at index 3. So 60 is less than, we can say, this is less than, or this is 80. So we will store 1, that is 80 is, because 80 is greater than 70, so we have to store the index of 80 into our answer vector. Next that is 60. For 60 also there is 60. For 60 there is 70 that is greater than 60, and it is next greater element of 60. So we need to store the index of 70, that is 3. that is at index 4, this is index 5, and this is index 6. After that, we need to find the greater element above 60. So above 75, sorry, above 75 there is only this 80. So we need to store the element index of this, that is 1. So on the left side, there is only one element that is greater than 75, that is nearest only one nearest element that is greater than 75 is 80, and it has an index 1. So we need to store that in our answer vector. So I have stored this, and now we need to find the nearest greater element to the left side for 85, that is 100, which is at index 0. So we need to store it at this. Now what will I do? Simply, this is our answer vector, this is our answer vector. So simply what I will do, simply I will iterate into whole array, and simply I will do this, that is I minus, that is element at this, that is array vector, sorry, that is answer vector, element of answer vector, that is this for loop will be run from 0 to n into our whole array, this is from 0 to n. So this will be for index I, that is for 0, that is minus, that is ARR of I, that is -1, that is minus minus plus 1, that is 1. The first element will be 1, second element will be, that is that is 0 minus, sorry, 1 minus, for I equal to 1, 1 minus, that is ARR of 1, that is 0. So there is another one, 1 1, and for 2 there will be 2 minus 1, that is 1. For 3 minus, that is ARR of 3, that is 3 minus 1, that is 2. For index 4, that is ARR of 4, 4 minus ARR of 4, that is 1. And for 5 minus 1, that is 5 minus 1 is, that is 4. And at the last there is 6 minus 0, that is 6. So this will be our final answer, that is 2146. That will be our correct answer. So simply what we are doing here is simply the logic behind the whole, intuition behind this whole question, we can say intuition behind this question is simply we have to find the nearest, we can say nearest greatest element to the left side. So there, what we are doing is we are doing two steps here. Step 1 is, that is step 1, we are simply finding the indexes of nearest greatest element, we can say nearest greater element, and we need to store them in our answer vector, store them in in our answer vector. Okay, so this is step 1, and second there is step 2. So after finding the, we can say after finding the indexes, and after storing it into our answer vector, then we have, what we have to do, we have to simply iterate through the whole array from that is from 0 to that size of an array, and we need to find the, simply we have to do this system, that is ARR of I is equal to I minus ARR of that is this is answer. So we have to do these two steps for finding the solution of this question. So here so we are taking the stack, and we are taking stack, and the we are taking into a pair, because we need to store the element as well as their indexes for comparison purpose. So we need to you can say declare the stack inside the pair. We need to declare the stack inside the pair. So after that we have taken an answer vector that will simply store the our answer, we can say our answer. So simply we in this process, whole process, we are doing we are finding the nearest greatest element to the left side of the array. So after finding that, we need to, after that we are having the indexes of the nearest greatest element, and we need to subtract them with our current, that is current index of the array. So simply after that we have to return that. So let's discuss the time complexity for this approach, you can say. So as we are using one extra auxiliary space, so it will take, we can say it will take it will take big of n, because because we are iterating the whole array once, and we are storing it into the our answer vector. So this is space complexity, that will be big O of n. And let's discuss the time complexity for this. So time complexity will be also big O of n, because we are iterating the whole array at once. So big O of n will be the, you can say this is size of an array, size of price array, that is price array. So this will be the time complexity and space complexity for this question. So in the next, we can say in the next question, what we have to do is simply we will move to our next question, that is valid parenthesis. So let's see the question. So we have given a string s that will be containing in characters. So we have given a string, and that will contain these simply these characters. These are simply brackets and nothing else. So this will be containing our string will contain these characters. Okay, we need to determine the string is valid or not. So if string is valid if the open, we can say the open and close brackets are of same type, and the open and close bracket must be in sort order. So okay, So let's discuss this question with the help of this test case. So for example, we have this, I can say this is input, that's string, and I have this bracket. So the first rule here is if the order of bracket should be in correct manner. So if I have the first string in this manner, this will be wrong. So order needs to be in the correct manner. So this will be our first rule. And second rule is, if I have, for example, if I have this that is opening bracket of type this, so the closing bracket should be of this type only, that is this type. Not we are simply, if we have this curly braces, so this order, so this will be not the correct order. So the correct order will be this. So open and close bracket should be of same order. So, and the third rule is, if our string is valid if every close bracket has corresponding open bracket of same times. For example, if I have this, we can say, if I have this bracket, so for this close bracket there should be an open bracket present of this type only. So that will be an valid string. For example, if there is, if this open bracket is present, it is valid, valid, I can say valid parenthesis. And for example, if I have this and I have this, and I do not have this open bracket, so this will be our, we can say wrong, we can say invalid string. So how we will do? So simple approach will be, how we will do this. So we will take with the help the help of stack. So what we will do, if our stack is empty, first of all what we will do, simply we will insert the opening brackets of the strings. So for example, in this test case, for example, this is our test case. So if I put the first bracket, that is inside the stack, this will be this. And if our we will compare this, we can say this top element with our next bracket, that is if it is of same type and have close and has opposite direction, then we need to pop this element from the stack, and our stack become empty. So it means there are valid we can say parenthesis present inside the stack. So this needs, if this condition, if our output is true, if our stack, that is s dot size, we can say 0, s dot size equal to 0, then we need to return the true. Or we can say, if our stack is empty, we need to return true, because if we are found the valid from parenthesis of same time, we need to simply pop that parenthesis from the stack, and we will get the empty stack. So we need to return the true. So let's understand this approach with the help of the code. So here I have taken an stack, and I am iterating with the whole string, that is s. So I will check if we can say, I will check if our string that is I is open bracket, then we need to push that that string inside the stack, and after that I will check if our, that is we can say our stack is empty. So if our stack is empty, so we are getting the bracket in opposite direction, so we need to return the false. Or we have this condition, there are three conditions. If our stack dot top has this open bracket and the I does not have this, that is close bracket, so this will also, we can say, the current element does not match the top of the stack. So simply it means that the current element is a closing bracket. So we need to two condition: current element matches with the top element and the stack will be not empty. If control reaches to the line, it means we got the right pair of the bracket. So if these conditions are, we can say, if these conditions are true, then we need to return the false. After that we need to simply pop that pop from the stack, and after that we have to return true. If our stack is empty, then we have to return the true. So this condition means if we are getting the bracket in opposite direction, so the current element is a closing. For example, if we are not getting the open, we can say open bracket, then in else case we are getting the close bracket. Or we will check the two condition. If our st top is open bracket, then we and our I is not equal to this close bracket, or we can say this happening, so we need to return the false, else we have to return the pop. So simply here is simply we can say simple intuition is simply we are comparing the top element of stack with the current string. So if both are of opposite direction, then we need to pop that element from the stack. And if our brackets are valid strings, then the size of the array will be 0, always 0. So this will return the true. So I hope this will get into this intuition will get into your mind. And yeah, that's about for today.